dear students, welcome back 9th class. Today is my first session with you all. That is, I'll start with chemistry session today. I'll also continue with bio and physics with you all. Right? So I'm going to start with the first chapter in chemistry, that is matter in our surrounding. Now the thing is, what actually the matter is. Okay? Anything which occupies space and has its own mass, then it is known as matter. Anything, I'm saying, maybe the biggest object or the smallest. If I matter, the two conditions, it should occupy space and has its own mass. Then we will call it as a matter. If I'm talking about, suppose this is the dot. This is the dot. Is this a matter, student? Is this a matter? Yes. This is also a matter because at least this is occupying space, the dot, and this dot has some mass of ink is there. That is why the smallest particle as well as the biggest object, then it is also known as matter. Anything bigger or smaller, biggest or smallest, that occupies space and has its own mass, then it is known as matter. Next is, then what is non-matter? Non-matter, vice versa, which is not occupying space and has no mass, then it is known as non-matter. Then what are the non-matter? All the feelings or the abstract noun, love, hate, these are all feelings which are there, fire, these are all what? This is non-matter. Clear? All the abstract noun you can also call, those are which is not occupying space and has its own mass. Clear, student? This is the first topic, that is matter. Now, how can we classify matter? How can we classify matter? Ancient Greek philosophers, initially, they said that matter is made up of 5 particles, 5 substances, that is known as Panchatattva. Panchatattva, it's a Sanskrit word. So Panchatattva means they talked about air, water, sky, fire and earth. This is the ancient I'm talking. Greek philosophers, they gave this idea first. Then again the scientists kept on researching and then they find that matter can be classified according to their physical and chemical properties. If I'm talking about physical properties, that means solid, liquid, gas. Matter exists in these forms, that is physical nature, that is solid, liquid and gas, which is common, and the other two more is there, that is plasma and Bose-Einstein condensate. Still the work is going on all these particles, all this matter. So there are now 5: solid, liquid, gas, plasma, Bose-Einstein condensate. Right? So, and chemical nature, earlier chapters, in my later chapters you will come to know atoms and molecules and structure of atom, what are these, when we will come across all these chemical reactions and all, that is chemical nature. So physical nature and chemical nature. In first chapter, I'll go with first physical nature of matter. Then in later chapters, we'll come to know about chemical nature. Right? Shall I start? So matter, classification and the physical nature of matter. Now, first property of matter is made up of particles. Matter is made up of particles. How will we prove this? By doing activity. What we will take? We'll take beaker full of water, and if we put some particles of salt or sugar, not both, salt or sugar. Now salt or sugar particles, when we see, it will dissolve in this, and we will find the transparent water. Now student, one thing I want to ask, if I am dissolving this, whether this level will rise or remain same? It will rise or remain same? Rise? No, it will not rise. It will remain same. Then where those particles goes? Where those particles goes then? If it remains same. Right? Now, come. Where those particles? So we know that in liquid particles, when we are talking about liquid, the particles are much apart from each other. There is little space, but there is a space between. Intermolecular space or interparticle space. Clear? There is space in between. Then what happens then if there is space? These salt or sugar particles will occupy the space in between the water molecules. See, there is a space and this space is occupied by salt or sugar molecule. Clear? So level will rise or same? It will remain same. It will remain same. One more question again. What will happen if we put some salt or sugar and water? Will the level of the water will rise or remain same? It will remain same. Why? Because the sugar particles will occupy the space in between the particles of water. Right? So this proves that what happens? One particle is occupying the space between the other particle, which is known as dissolving. Dissolving. Right? That means one particle and it has mass and which occupies the space between the other particle. That means I am talking about matter. Occupies space and has its own mass. So first physical nature, particles of matter occupy space. Clear? Come to next. Particles of matter are very, very small. Particles of matter are very, very small. How can we prove that? If I say the ultimate particle of matter is atom. Atom is the smallest particle which combines to form molecules. The particles of matter means matter, the ultimate particle is atom, combines to form molecule, then element, then compound, then mixture, then matter. This we'll discuss in our later chapters. So matter is made up of very, very small particles. How can we prove that? So small particles beyond our imagination, we can't see by our naked eyes. Clear? For that, there is activity 1.2 is there in your book. This is activity 1.2 in your NCERT book. So now here what we'll take? We will take 100 ml of clear water. We will take 100 ml of clear water and we put 1 or 2 crystals of potassium permanganate. Potassium permanganate, it is a chemical which when mixes with water becomes pinkish in color. So we'll add few crystals of potassium permanganate in this clear water and we will find that it becomes pink color solution. Right? Now what we will do, we'll take from this 100 ml 10 ml in the test tube. We will leave 90 ml. We'll take only 10 ml and again we will put this in 100 ml of clear water. Clear? Next again, what we'll do? Again we will take 10 ml of this water, colored water, and we'll leave 90 ml, 10 ml again in the clear water, 100 ml of clear water. This is the known as dilution. Means every step we are diluting this, means we are mixing it with water. Dilution. So if we go for 2 or 3 or 4 dilutions, then what will we find? The color of the solution becomes lighter and lighter. Color becomes lighter, that is fading away. Yes. Question. Yes, student? Ready? Question. Means why the color fades? Why the color fades? Here it is darker and when after 3 dilution or 4 dilution, the color fades away in every dilution. Then why the color is fading away? 100 ml. From this dark pink, we took only 10 ml. Again with clear water. Again light pink, 10 ml I took. Again in the clear water. And we will goes on, it becomes fading. Color becomes a light pink, lightish, lightish, lightish. Why the color is fading away, student? Anyone? No? Yes, I'm telling you. Don't worry. I'm there. Yes. Now, because the particles are decreasing, when we are starting from here, the number of particles are greater. As we continuously taking 10 and then diluting in water, the particles will keep on decreasing. That shows there are particles which is very, very small, but by fading away, we can come to know that the particles, what? Are decreasing. The number of particles are decreasing. That is why the color becomes what? Fades away. Clear? This proves that matter is made up of particles which is very, very small beyond our imagination. We can't imagine even. They are so small. Can't see from our naked eyes. Right? Now next is third. Matter occupies space. Particle occupies space. Already I have explained here that how it occupies space. One particle occupies the space between the other particles. Clear? Next, fourth. Matter, the particles of matter are continuously moving. Continuously moving, students. That means now we can't see air, but when we see that the particles of air are moving, in the darker room from the slit, if the light enters, flash of light enters, what you see? The particles of dust particles you can see is moving. Am I right? So that shows, otherwise if you are in open room, you can't see this. But when you are in darker room and one slit is there, early morning you can see this in your darker room, that if from that slit the sunlight is entering, you can see the, yes students, you can see the particles, dust particles of the air can be seen in that flash of light. Clear? That shows that particles are continuously moving. Clear? Another example, incense stick. Incense stick, agarbatti. Right? So incense stick, when we put the, when we burn that incense stick, what happens? We can see the aroma of that incense stick can be felt in next room. That means through air it is moving and reaching to the next room. Or the deos or the perfume, these can be seen. These can be felt. That you are feeling that the smell or the aroma of that is coming there. That shows that particles of matter continuously moves. Suppose you take a drop of Dettol and a beaker of water. If you put the drop of Dettol in it, you can see the white colored solution. This is how it enters. You can do this activity at your home. If you put the drop of ink, you can see this. Again, the particles are slowly, gradually mixing it up with water on its own. That means the particles of matter may be solid or liquid, not solid, no liquid or gas. It is continuously moving. Solid, they are so tightly packed, so this not happens there. Right? Now, this continuously moving and the what transferring from one place to another is known as diffusion. So what is diffusion? It is the, yes, it is the spontaneous flow of particles from high concentration to low concentration on its own. High concentration, suppose I am spraying dew over here. This is high concentration. Next room it is reaching. Aroma is reaching. Then high concentration to low concentration. It will never from low to high. Students, never from, diffusion will never from low concentration to high. It is always from high concentration to low concentration. So what is diffusion then? The spontaneous flow of gaseous particles from, yes, high concentration to low concentration on its own is known as diffusion. More the temperature, more the diffusion is. Much faster the particles will move. How it happens? Diffusion. Suppose if I am saying this is the water with salt and all and I am putting burner over here. Okay? Now this is the burner. What happens? I am giving heat. I am providing heat to this. Then what happens to this water? After some time we will see that the particles are moving and starts boiling. They are jumping. That time the diffusion is faster. Diffusion is faster. Increase in heat increases the kinetic energy of the particles. Kinetic energy means when the particles are moving, they gain energy with it and known as they collide with each other, known as kinetic energy. This I'll explain you in conversion of states of matter. That time I'll explain you in detail in my next video. Clear? So, diffusion is faster when the heat is provided. Very good example. You are cooking. Your mother is cooking in kitchen and the aroma of that hot sizzling food you can feel to next room. That means hot sizzling food means temperature is high, so the diffusion is faster and you can. If the cold food is there, you can't get that aroma than the food which is still being cooked. That is, the vapors are releasing into the air and fast diffusion. So question 2 marks in your NCERT only. Why the aroma of the hot sizzling food can be felt rather than cold food? Yes, due to diffusion. That is, the diffusion, greater the temperature, greater the diffusion, greater the kinetic energy of the particles, and high concentration to low concentration, the gaseous particles will move. And we can smell hot sizzling food. We can smell the aroma of hot sizzling food. Yes, students? Clear? So these are the conceptual study. You are now in advanced class. That means senior section you have entered. Whatever you are understanding should be conceptual. Should be conceptual. Clear? Now the last point, first point. What is first point? Yes? Matter is made up of particle. Matter, the particles of matter are very small, beyond our imagination. Matter, particles of matter continuously moving. Particles of matter occupy space, and the last, particles of matter attract each other. Particles of matter attract each other. How can we prove this? In your NCERT, there is an activity 1.6. In that you can see the dancing girls were standing. 4 dancing girls were there. Now what we will do in this activity, 4 groups of dancing girls we will take. First group will hold their hands finger to finger. Clear? Second group will, 4 girls, first group holding their hands finger to finger. Second group holding their hands hand to hand. And the third group, which is there in your book, will hold their hands in the locking system. Lock on each other. Clear? Fourth group was to break these hands or this channel. Clear? Now fourth group is coming and started. Now which will break faster? Which will break faster? Girls, those who are holding their hands finger to finger. Then hand to hand can be easier, but locking system, it is a little difficult, but it will break. So what does this activity show, student? Yes, tell me, what does this activity shows? Yes, those who are holding their hands finger to finger, that means they are gaseous particles. Hand to hand, liquid particles. Locking to each other, solid particles. Clear? So what happens then? Solid particles have strong force of attraction between them. See, there is attraction term came. Liquid particles have little attraction between them. Why? There is a little space in between. Gaseous particles, attraction is very low because they are far apart from each other. So this is force of attraction. So particles are attracting each other. Solid particles will attract much more than that of liquid, and liquid looser and gases will far apart. So attraction is very less. Clear? So these are the 5. Again I am recalling, particles of matter occupy space. Particle of matter very small, that is beyond our imagination. Particles of matter is made up of particles first. Next, particles of matter are continuously moving, and if the temperature is high, diffusion will take place and the particles will move much faster. Right? And the last one, particles of matter. But now there are some points, specific points that, like in your exam, it may come of 3 marks. Give the difference between solid, liquid and gas in concept of compressibility. Solid is always having fixed boundary. Liquid again takes the shape of ice. Solid can't be compressed. Why? The particles are tightly packed with each other. There is no space in between. So it can't be compressed. Liquid, little compressibility. little compressibility. It will compress, but not so much. But gas, very high compressibility. Very high, because the particles are far apart. If you pressurize, the gas will come closer and closer. Example, LPG, liquefied petroleum gas. Liquid is compressed. How it is compressed? By using piston. Piston, if you pressurize the gas, then what happens? Particles come closer. Okay? Closer and closer and converts into liquid. Clear? So, how the gas can be compressed? One more question. By increasing the pressure and decreasing the temperature. If I increase the temperature and pressure, the vessel will blast, cylinder will blast. So, how gas can be liquefied? By increasing the pressure and decreasing the temperature. One more question. Example, CNG, that is compressed natural gas, and LPG, liquefied petroleum gas. So, gases are highly compressible. Right? Next point is intermolecular space. Already you know, no intermolecular space because the particles are tightly packed with each other. Yes, there is a little space. Very far apart means much space is there. Why Almira is solid? Question is there. Tell me the answer. Why Almira is solid? Because there is no intermolecular space in between and the particles are tightly packed with each other. Why the tap water can be cut with a finger? Why the water which is coming out from the tap can be cut with a finger? See, these are all one reasoning question comes. Why? Why we can? Because there is a little space in between the liquid particles and we can easily cross our finger from that. Yes, student? These are type of questions comes. Yes. Now, next is melting and boiling point. What is melting point? The lowest temperature at which the solid get converted into liquid state. Solid is melting into liquid state. So, when it will melt easily? When there is a space enough in it. If it is tightly packed, it will take time. It will melt. But if you want to melt candle and iron, so which will melt faster? Candle. Clear? Though it is a solid, but when you are melting, it is very fast melting because space between becomes easier. But in solid, they are so tightly packed. It will also melt, but take high temperature. So, what is melting point? The lowest temperature at which starts melting. Clear? Boiling point, the temperature at which starts boiling. Very fast boiling, very low boiling depends upon the particles. Now, if I am talking about melting and boiling point in solid, particles are very tightly packed with each other. It is very difficult to boil as well as to melt. So, what will say? Very high melting and boiling point. Very high. Low nahi bologe. You will not say low. High melting and boiling point means it is very difficult to melt as well as to boil the solid particles because their particles are tightly packed with each other. Clear? Liquid? Yes, it can melt easily. It can boil easily. Clear? Gaseous? Very high, very low melting and boiling point. Low. Now you will say low. Liquid? Low melting and boiling point. Clear? Gaseous? Very low melting and boiling point. Solid, very high melting and boiling point. High means not easy. Right? Next come fluidity. What is fluidity? Can flow. Fluidity means can flow. Solid can flow easily? No. What is the reason? Same reason. Particles are tightly packed, so they can't flow. So what will you say? Fluidity? Very what? Fluidity? Low or high? Yes, students? What you will say? Very low fluidity, can't flow. Liquid can flow, high fluidity. Gaseous, very high fluidity, flow much faster because the particles are far apart. Clear? Next come density, mass per unit volume. Density, how much it is weight. That means density means how much heavy it is or lighter it is. Solid, high density because mass per unit volume is very high. Liquid, low density, very low density is gas. Right? And the last is diffusion. Solid can't diffuse much faster because particles are tightly intact with each other. So diffusion is very low. Diffusion is little What? Higher than solid. And in gas, the diffusion is very high. Clear, student? These are the differences between, so the complete difference will never come. They'll give these points in concept of this. This is one NCERT question is there. Give the difference between solid, liquid and gas in concept of these points. Any of 4 or 3 points, so 3 marks they will give. So, concept should be clear. Clear? If any doubt you people are getting, students, please write me in the comment section. Clear? First video I am sharing it with you all. Now I'll continue with all this next lecture. So please, if you like, please share and subscribe. Clear? Thank you so much, student. Thank you so much with me.